We're here showcasing our ITS incident detection system and demonstrating the capabilities of that and explaining to people how it may be able to help them improve the safety on their roads, throughput on their roads, and also providing traffic data. The system can provide a wide range of outputs depending on what the road operator would like. So for example, stop vehicle detection is one of the sort of fundamental capabilities of the system, but you could also be looking for wildlife detection, pedestrian detection, wrong way driving, and we can also do count and classifying vehicles in each lane and counting how many vehicles travel in each lane. We can also do things like intersection monitoring as well. So it very much depends on what the customer wants. We track all the vehicles across the highway in all the lanes from a single location, each sensor covering 700, 800 meters, and then we analyze that data, and if the customer wants a particular piece of information, we can give it to them. But what the radar does is a high frequency imaging radar. It's a fairly sophisticated radar solution. It provides full scanning of the surrounding environment, providing an image to then analyze and provide the data they need. The big advantage of radar, and the reason why we use radar, is that it's immune to different light conditions, weather conditions, fog, snow, dust, smoke. It doesn't get affected by any of those things. As people are aware, radar is used for military, marine, and aviation applications, all for very good reasons. It's the chosen technology for long-range, all-weather sensing, and that's why we use it for this application. And if you think about the circumstances under which you would most likely need an incident detection system to know what's going on the road, is when drivers are least effective, and that is in poor visibility environments. So actually you must have a sensor that works when visibility is poor, because that's when drivers are compromised most. So hence we use radar. So we were involved with the project in New Zealand. I think it's actually maybe the first motorway in New Zealand where the project is to provide a full analysis of the road, so that the road operator in this case is actually paid on the data that the radar collects. So they're paid on the throughput of the road. They need a system to actually measure the throughput of the road, so we provide that, but we also provide stop vehicle detection, wrong way driving, we provide debris detection and wildlife detection. They're also looking at debris from rock falls going onto the road as well, so that we can detect that so that cars don't hit that. And that's very much in keeping with the other applications. For example, here in the US there's a temporary hard shoulder. I think it's part-time shoulder use, I think is the terminology they use, where they want to open up the hard shoulder, and before they do that, they would like to check whether anything is in the hard shoulder. The last thing you want to do is open up the hard shoulder, the car then drives into a stationary vehicle that's there, or anything else that's there, in fact, or any debris. So the system can provide all that information to the operator, doing two main things: increasing the safety of the road and also improving the throughput of the road. So it works in both ways. So one of our largest deployments is in the UK for stop vehicle detection on smart motorways. And as some people might be aware, that one of the issues with smart motorways is the potential safety concerns about stop vehicles in a live lane. So our system detects the stop vehicle and informs the road authority that there is a stop vehicle. And there we are looking for very high detection rates, because you obviously don't want to miss anything, and very low false alarm rates. So in the UK we monitor over 300 miles of motorway, and you can imagine if you were to have a detection rate from a sensor that was one false alarm every few hours, if you're sitting in the control center, you're going to end up with hundreds of false alarms. So your false alarm rate for those kind of large deployments needs to be extremely low to make it operationally effective. So we achieve that, and we have over 1,000. I think in the end we'll have about 1,500 units deployed on the UK highways, and there we are really honing in the performance of the system to deliver extremely high detection rates and extremely low false alarm rates.